listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned, as always, to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email, education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle, @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hello learners, you are welcome to edition of Computer Studies under Kaduna State e-learning program. My name is Mrs. Bangbelu O. Adeola. This morning we are going to discuss about the topic Logic Circuit 1, Standard Single Logic Gates. And under this topic we are going to discuss the followings: the definition of logic gates. We are going to list the types of logic gates that we have. At the same time, we are going to identify the symbol of each logic gate, recognize and state the input-output signal of each logic gate. Still in this period, we are going to construct truth table for each logic gate and the simple equation for each logic gate. Finally, we are going to consider the uses of logic gates. Now, what is the definition? What do we understand by logic gates? Logic gate is described as an elementary building block of a digit circuit, or it can be described as an electronic device that is used to control the flow of signal in a computer. When you are talking of the signal in a computer, we are talking of the language that computer understands, which is the binary number. These binary numbers are 1 and 0. 1 stands for on, while 0 stands for off. 1 is talking of high, while 0 is talking of low. If we understand that, we can still check from our motherboard in our computer system. We have a lot of parts like diode, transistor. If this one that is controlling the movement of our 1 and 0, and this is why we are having logic gates. Now, what are the types of logic gates that we are having? We have 3 types of logic gates. 1, AND gate, 2, OR gate, and finally the NOT gate. If we understand the type of logic gate that we are having, what are the symbols that represent each one of them? This first one is the one that represents input, the AND gate, followed by OR gate, and finally by NOT gate. The three of them are having inputs. 2 or more inputs is applicable under AND gate. The same thing applicable to OR gate. It is only NOT gate that is having just single inputs and one output. Now we are going to the next aspect. What are the inputs and output signal of each logic gate? When you are talking of AND gates, this is a logic gate whose output is high, meaning that the output here is 1. Only when all, meaning that input A, input B is low, is high. That is, the output is 1 and the 2 output inputs of the AND gate must be 1. That means, in other words, the output is low. Now, let's check the OR gate. The OR gate is a circuit that has 2 or more inputs. This is one input, this is the second input, and operates in such a way that its output is high, meaning that the logic is 1. If either the input A or the input B or both of them are at logic 1, the OR gate's output will be low, only if all its inputs at logic 0. Let's consider the third logic gate. The third logic gate is NOT gate. And I've said it earlier before that is the only logic gate that has just only one input and one output. This is the logic gate that has one input and one output, such that when the input is true, the output is false. That is why we are having this complement. If we understand that, we are moving to the next aspect, which is the equation of these 3 logic gates. The equation is talking about x equals a dot b. This, note that does not mean multiplication. This equation reads x equals to a or b, which simply means that the output of the gate is a logic 1 when A and B inputs are on their one stage. What am I saying is that input x, output x is 1 when input A and input B, when both of them are 1. That is when we have our output to be 1. OR gate equation is x equals a plus b. Note that this symbol plus does not mean addition. The equation reads x equals a or b, which simply means that the output of the gate is a logic 1 if either the input A or the input B or both at logic 1. Meaning that the 2 inputs A and input B, if we are having 1 or either of the 2 is having 1, then our output remain as 1, which means our output is on. Now, the next equation, which is the last equation, is talking about NOT gate equation. NOT gate equation is talking about A equals A complement or prime. Let's check. The complement bar, also called an over bar, is placed over the assigned input letter. The expression reads as A is equal to not A, which simply means that output state is opposite of the logic gate state applies to the input. Meaning that if A is on, the reverse is the case when it comes to output. With all this, we are going to consider the construction of the truth table of all the gates that we are having. Let's go to the construction table of AND gates. If we not notice, this is the symbol that I said is meant for AND gate. This symbol, before you can construct the AND gate, you are going to be given inputs between 2 and more of inputs. Now, if you look at the one that I'm having up here, the input is just 2. And there is a formula that will guide you in constructing these inputs. The formula is 2 raised to power n. N means the numbers of inputs that you are having, which will help you in your zeros and 1. Since we understand that our computer only understands binary number, and these binary numbers are 0 and 1. If you raise your power to be 2, your on and off, your 1 and 0 will be 4. Where in this sense, we are for the first input, since we have 4, it's going to be 0, 0, 1, 1. 0, 1, 0, 1. And for you to now know the inputs, there is a rule that guides your AND gate. Meaning that for your output to be 1, for your output to be on, you have to have both input A and input B to be 1. Let's check if we really constructed it well. From input A, with the equation that I gave you before, that under AND gate, X equals A dot B. If you look at it, we have 0, we have 0. So it doesn't comply. Definitely our output will be 0. We have 0, we have 1. It's still 0. Because they are not in the state of 1, 1, which is not on. We have 1, we have 0. Our output is still 0. But by the rules that guide AND gates, our output must be on 1, logic 1. Meaning that when you check input A, it has on, which is 1. It has on, which is 1. Definitely our output will be 1, which is on. Now, let's go to the next gate, which is our OR gate. When you check the equation that I gave you before, I said X equals A, input A plus input B. by the rules of this construction table of OR, either A or B that is having 1, your output will definitely have 1. Or if both of them are having 1 which is on, then your output will still remain as 1. Let's check it because we have 2 inputs, 0, 0, 0. 0, 1, 0. Since one of the output is having 1, then our input is having 1, our output will definitely have 1. When you check this next one, you will see that our input is 1, our output is 0, then our input will be 1. Now, coming to this side, the last one, our input is under input A is 1, which is on, is 1 again under input B, which is 1. Then finally, our output will be 1, since it complies with the rules that guys not all gates. Now let's see the truth table of the NOT gate. I told you that we're having just only 1 input under NOT gate, and then if our input is 0, definitely the reverse is the case. That is why we are having this bar up. So when you check the output, input A is 0 and our output is definitely 1. When it is forced on here, our output will be off by having 0. With all this, let's quickly see the uses of our logic gates. Logic gates are widely used in various applications, such as electronics. In any electronics, our logic gate is applicable in building of them. And when you check your watches, you check your calculators, you check your computer, mobile phone, is the work of our logic gates. Another one is in terms of decision, which can be yes or no as our outputs. Then the last one, we use them to construct the alarm that we use at home. When you are outside, somebody will press your bell, you will receive it inside, meaning that the signal tells you that somebody is outside waiting for you. I think with the little that I've said, you really gain on the topic called logic gates. I will call Mr. Ezekiel Anthony to come and recap the topic.
Hi learners, I believe learning have been interesting on logic gates under the subject computer studies. I will just make a summary of what my colleague have actually said. From the beginning we saw that a logic gate is an electronic device that actually controls the flows of signals in a computer system. And we were made to also understand that this very flow of signals we can see especially in our motherboard, which is embedded in the computer. It's made up of transistors, circuits, and every signal for on, for off, for the flow of data, for the flow of one charge or the other that is done in the computer is being controlled by what? These logic gates. And these logic gates, we said, they are derived from what? The binary number. Binary numbers are numbers made up of zeros and one. And that is the only language the computer understands. And we saw that some of this logic gates application constitutes of devices such as our wristwatches. When we check our computer, and like our fans and our bulb, we have on and off and so on, the way we control our electronic devices, they consist of these logic gates. We have inverters that are also made up of these logic gates. All they do is to control the flow of signals in an electronic device. And very important, student, for us to note that on, or the number 1, stands for high, or on, or through. Then the number 0, which is still the binary, stands for low, and also stands for off, and also stands for false. So when you hear any of this term, they are used interchangeably, or anywhere it's used where 0 is called, the first thing that should come to your mind is either on, or high, or through. The same thing for 0. So sorry, for 1, we have on, high, and also true. For 0, we have low, false, and also no. So we actually saw that we have basically 3 basic types of logic gates. We have other types, but the basic ones, or the standard, are what 3? The AND gate, the OR gate, and the NOT gate. And we saw that the AND gate is what? Having a symbol of a dot, which is in form of multiplication. And we further on discussed that for our output, since we are going to have an input, for us to have an output, there cannot be an output without an input. So for our output to be 1, the condition is that the 2 inputs must be 1 to give us what? Our output 1. That's for AND gate. Otherwise, the output will be 0. And we're also able to see that for our OR gate, the input or the output is 1 when we have either of the inputs to be 1 or the entire inputs are 1. But in a case where we have the entire inputs to be 0, our output is what? 0, which signifies low. Then we also saw the NOT gate. The NOT gate symbolizes an inverter. Some people will call it inverter because it works in what? In an inverse way, whereby where our input is true, our output becomes false. If our input is false, our output becomes true. So it works interchangeably, and that's how it works for the NOT gate. And we're also able to see the truth table. We saw the symbols, which was demonstrated by my colleague here. We saw how they look like, and students should note that most of this can come up in questions in your work. You'll be asked to draw the symbols for the OR gate, AND gate, and you should know the graphical representation, and you should be able to write the equations and also draw the truth table and know how to position your inputs and have your corresponding outputs. So I believe you have learned a lot, and I believe with further studies, you'll be able to do better. But we're not going to leave you idle. We're going to be keeping you busy with an assignment to help you actually see to what you have been taught, and we're going to test your ability to know whether you have learned something or not. And the assignment goes thus. The number 1 assignment requires you to define a logic gate. Number 2, you identify the type of logic gate from the following gate symbols. We have the symbols that are being drawn here respectively. We have the triangular symbol, we have the half curve symbol, and we have the other one right there with their arrows of direction. Then we also have the number 3 question: state the output signal of the following. We have a table already with 2 inputs, input A and input B. You are required to put in the missing. When we check the outputs, we need all of the outputs. You can see a question mark on all. For AND gate, we have input A to be 1 and input B to be 1. What is the output? For OR gate, we have input A to be 0 and also input B to be 0. What is the output? That is what we require. And for NOT gate, which we know we have only 1 input and also 1 output, we have the input to be 1. What is the output? Then the number 4 question, we have state 3 uses of the logic gate. It's very important for you to know. State 3 uses of the logic gate. Then the 5th question is write a logic equation for A, NOT, B, OR gate, C, AND gate. Thank you very much for listening. We believe you have been impacted, And for further questions, if you have questions, and when you're able to solve this assignment, you can send it to us either via WhatsApp or via text messages so we could see and make adequate corrections if need be. And you can contact the first person, Mrs. Adeola, on 080-3600-3145 and Ezekiel Anthony on 080-364-20271. I take the number again, Mrs. Adeola, 080-3600-3145. Mr. Ezekiel Anthony, 080-3642-0271. Thank you for listening, and God bless you.